Hello everybody. I am Benoît Sutor from iMio, here from Belgium. And today I will present you how we create, deploy, and update over 300 websites at iMio with no downtime during this process we started 6 years ago, 6 or 7, and maybe now we are at the end. About this presentation, it's available on GitHub on my GitHub account. And I use Markdown slides to generate it. It's a Python egg. You can install it easily. I will start with a little introduction of our CI. After I explain how we transform our build-outs to work to create a CI, and we use Docker for that too. We set some environments. After we create the CI/CD with Jenkins and Rundeck, and we use Puppet to also as automation code, infrastructure code. And we'll make a little demo of our CI. As a tradition, we create over 300 websites developed in Plone with one build-out, and we update all this website with build-out. Of course, at the beginning it was really easy because we had a few clients, maybe 4 or 5, but it's growing fast. And when we begin to have 10 and 20 clients, it was very difficult to update. Maybe if you have a little change on the CSS file, you don't want to go on the SSH and web server, make a git pull or something like a bin build out or something like that. So we decide to create a process to update them all, and we start thinking as DevOps enterprise and as DevOps process. We want to see also to avoid human errors. I think everybody here know maybe some dev who make mistake on server production, like rm.rf/, who just delete all your system information system on Linux. You also maybe know devs who make bug fix directly on production. It's some things it's okay, but some things sometimes it's really not good, and we have a lot of problems with that. We don't want anymore. So we decide to make small and frequent releases, because when you make a release every I don't know 6 months, it's very difficult to remember what you have coded during the last 6 months. And if we decide, okay, every Monday we make release where we are, you know what we have done. We remember what we have done last week, so it's easier to change, to find the bug and to update it and correct it. Sorry. We also want to junior dev be able to make a release easily. So when senior dev is on make other things, junior dev can make a release if the client he asks to do that directly or something like that. So we want to use also the same tools the devs use every day. Every day we work for Python, so we make release on PyP, and so we use zest.releaser for that. I don't know if you know these tools, but it's really easy to make release for Python X with that. It's you update your changelog files with the date of the release. You push it on PyP, and you update the version 2. So we decide to use zest.releaser to see if you want to use that if you can use that. And we read the code of zest.releaser, and we see that with just a version .txt file and a changelog entry, you can make a release of any repository. And so it's done. We just add 2 files on your buildout repository, and after that we are able to make full release. And another advantage of that is we have a clear change of what we have in the new version. We can share it with our clients, and I think it's a good thing. We don't think at that when you choose to use the resource, but when you, of course, dev have to make copy-paste the change of the build-out repository, but it's not a lot of things to do. We also decide to build a Docker image to package our code base. Before that, we use egg to deb, sorry, to do that, but we think it's when Docker arrives, we think it's a good solution for doing that. It was 6 years ago, so now when you commit a new message, change a new build out, every time a new Docker image is created and push out to your own registry, Docker registry. And the build can fail if you have a network problem or a package is not pinned on the build out or so on. We also decide to test Docker image when this image is built. For example, at the beginning we just test if we're listening in the log if we have the ZOP is ready and something like this, and we also test if the REST with the REST API if a policy is installed. We use a policy to make all the policy. It's a package. It's on Pipey, and it's in the package we make all the dependencies on it in the set API. So when you in your build out, we have only one egg. This is the policy, and the policy download all the package dependency you have. An example for a test with the compose and PyTest. It's simply we start the Plone, we make a timeout of 60 seconds, and we loop on the logs. On Plone 6, we wait, listen at on the logs, and if it's arrived on the log, it's okay. It's Plone is ready. So the instance is able to start. We also make we use requests to request library to check if our policy is installed. And just with these 2 tests, we have a lot of things with a lot of things tested in fact. Okay, so we decided to make 3 environments. I think it's very classical. The devs one, we decided to not use Docker as dev env because you can do it. We think is we try it and we think it's easier to use build out directly with pip, Mr. Dropper, derenv, and pre-commit and so on. We create staging environment. This environment is always updated. When you change something on your code base, it's arrive automatically on staging. But on production, not production. It should be human action or something to check something if to go to production. not automatically. So staging, when a new commit is pushed on your buildout repository, the CI starts and it creates a new image, test the image, and deploy it with a rundeck. I will explain that a little later. And production, it's on your CI on Jenkinsfile. When you create a new tag, it is detected by the CI, and so the latest staging image is Docker image is copied from staging registry to production registry, and after rundeck, I will explain later also, start the production update. So how you do all that? We use Jenkins for that. When we start, GitLab CI did not exist, so it's why we use Jenkins. At this moment, it was the best tools, I think. Now, maybe it is also, but I'm not sure. It's another question. So we use Jenkins to scan all our build-out repository and organization on GitHub. And when Jenkins detects a Jenkins file on one of your repository, it automatically creates a CI. And our pipeline is like that on Jenkins. So there is a lot of stage, which we work on main branch, but we can also, for test, create another branch, and with that we create an image with another name, that's the latest name, and for example, Plone conf 2022 as the name of branch. It would create a Docker image with the tag with the same name as the branch, and push it on the registry. After that, we can change your staging instance for using it. So Jenkinsfile, there is a lot of stage. For example, here we can see the build of the main branch. When the CI go there, when you is on. Sorry, it's a main branch. I check if there is no CI skip on the changelog commit, and on the last commit message. I check, as you know, when you use full release from the releaser, when you make a release, a commit message is always back to development or prepare release. So we skip that also for we don't want to build a new image when you make a full release. And after we build the image. After this stage, we test it, as I explained before. We use Makefile for that, but it's the test with PyP and the PyTest and Docker Compose. After that, we check if next stage we check if build is a success. No problem with the build and with the test. We check if there is no CI skips also on the changelog, and we start the rundeck job on rundeck for updating our staging instances. So rundeck is tools, open source tools, but there is also enterprise version, not free, but the open source is free. We use this one, and there is a lot. Every server have a rundeck agent installed on it, and rundeck can go of every server you have, and rundeck can start everything on the server. But you can say, go to server 1, 2, 3, 4 and make Docker and make a command Docker pull of the new image and restart the service. So it's what we done. We define one job for restarting the staging instance, one other for the production instance, one other to make a lot of job. And we also need to know that the run deck will restart instance one by one. We use rare storage for our instance now with on Plone 6, and so we restart one instance. We have always two instances running, so we can stop the instance one, wait the restart with a new version of the latest Docker image, and after we can start all upgrade step. And when it's okay, when the instance is ready, we restart the instance 2. So we have no downtime with that. It works pretty well. After that, the next stage is the deploy stage, but we make that only when a tag is detected by the CI. So when you make a full release and you push a tag on the GitHub repository, so we copy the image from staging to production. We start a run deck job, and we send an email just to, in this email we add a link to the changes. So we have, everybody in the team knows when a release is arrive, and you have the change log on one click. With one click. So when a new tag arrives on the pipeline, it skips all the stage except the deploy stage. It's the goal, of course, of that. And you can see here he copied the image from staging to production, and he started a run deck and he sent an email. We also use Puppet as infrastructure automation. So Puppet is like Ansible. The goal is the same, but also 8 years ago, Ansible was the beginning. Puppet was more maybe better at this time. And also we have Puppet now on production. For Puppet now, we use it to create the systemd files. So every Docker Compose is a service started with systemd. We have I don't know, 10 Docker Compose repository on a server, and 10 systemd files, which create update systemctl restart service 1. I don't know the name. We use Puppet also for the cron, for the backup, on the pack, and so on. Puppet you also use for creating Apache aliases. Now the whole process there takes a lot of iteration to work. It was fine now, but need some improvements. We cannot detect easily the need of a new instance. Maybe under an attack of something like this, it's not really easy to make an action with a Puppet and with a Jenkinsfile at this moment. And it's really, when the server should be restarted or something like that, instance could be moved automatically to another server, but we can do that with your process actually, not actually at this moment. So the next step for us, infrastructure team, is migration to Kubernetes with chart. We starting the process last week, so it's very the beginning of it. The very beginning. Okay, I have a little demo of this. We have on a buildout repository. I will make a branch. I will push this branch, or maybe make a change. sorry. I push this branch, and I hope Jenkins can see it. Ouais. Not yet, okay. Ah, there. Okay, you can see now he go to the stage, build another branch, and he will create an image with Plone conf 2.022 and push it on the Docker registry. And it's all. Thank you. Any question?
How do you clean up your systems for the extra Docker images that you have laying around after you've been building them?
We have a script on which run on a registry every weeks, and he keep the 10 last images, and he delete all other.
Okay.
I think it's tools from Docker. I don't remember the name. Yeah.
If something goes wrong in that automated deployment, how do you debug that?
Something like what?
You have this automated deployment queue.
Yeah.
And it gives you an error.
Okay, I read the logs on Jenkins, and Jenkins usually say, okay, it's failed there. Maybe sometimes it's a run tech job. If fail, I go to the run tech job and see what happens. But I ready with the logs.
Can you give examples, one or two examples for typical problems that you are facing? What is happening in such a job?
Okay, I can check here the failed job. Here, I don't know what's happened, but okay. It seems here there is a version not picked, not pinned, so.
So it is Plone stuff.
This Plone stuff, yeah. It's the buildout stuff, yeah.
Thank you.
Yes.
What does your Docker Compose setup look like? Is it one container per Docker Compose? What are you composing?
Your Docker Compose file is generated by Puppet. We create. We decide how many instances we would like. The default is 2, but for big municipalities we have 5 or 6 instances, and it generated. We say Puppet number of instances 2, and it generated to instance 1, instance 2 with that.
So you're combining identical containers?
Yeah. We just have one little difference. The first instance is the only one we can start the upgrade steps. No more question? So, thank you.